Hey guys, so I've done this video like tons of times, so hopefully this is the one. So today we are talking about the integrating factor method in solving first order linear differential equations. That's a whole mouthful. But anyway, so we're going to get started. Basically, the integrating factor method, we take an integrating factor that we solve for, then we multiply it by our differential equation so that it looks like what you would get using the product rule to take a derivative. And from there, we can find our y solution. So first things first, we need to figure out what our standard form for a first order linear diffie is going to look like. So that is y prime plus some function of t times y is equal to another function of t. If you had an x, you would use x. Instead of y prime, you could do dy dt, dy dx. Yeah, same thing. All right, so first things first, we need to get our equation, which is ty prime plus y equals sine of t, to look like that equation. So let's divide all the way across by t to get y prime plus 1 over t times y is equal to sine of t over t. And if you look on the right there, we do have an initial value, but we'll talk about that in just a second. So now that we've gotten our equation into standard form, we need to solve for our integrating factor, which is going to be mu of t. And from the theorem, we know that that is equal to e to the integral of p of t dt. Now, what is p of t? Well, if we match our equation to that standard form up there, we see that p of t in this case is going to equal 1 over t. So all we have to do is plug that in, and we are set. So plugging it in and solving, we get e to the integral of 1 over t dt. And from Cal 1, we know that that integral is just equal to the natural log of t. Our e and our natural log cancel out, and all we are left with is mu of t equals t. Easy enough. So that is our integrating factor. Now what we want to do is plug that into our general solution form. And that is going to look like this. We have mu of t times y is equal to the integral of mu of t times g of t dt. And again, from our standard form and matching it with our equation, we see that g of t is equal to sine of t over t. So now we have everything we need, and we can plug in and solve. Mu of t, we get t times y is equal to the integral of t times sine of t over t dt. And again, those t's just cancel out. So all we need to do is take the integral of sine of t. Ty is equal to negative cosine of t, again from Cal 1, plus c, don't want to forget that. And then all we need to do is isolate for y. So dividing by t all the way across, we get y is equal to negative cosine of t over t plus c over t. And that, friends, is our general solution. Now, usually, if you were just asking for a general solution, we would be done with our problem, yay! But we were given an initial value, which is up here, y of pi over 2 is equal to 1. So we want to find the solution for this initial value problem. So all we have to do is plug those values into our general solution, and we can solve and get what we need. So I'm going to move over to this side. So we get, we get 1 is equal to negative cosine of pi over 2 over pi over 2 plus c over pi over 2. Basic trig, we know that cosine and negative cosine of pi over 2 is just 0. So we have 0 plus c over pi over 2. That 0 is just going to get out of there. And then all we have to do is multiply by pi over 2 all the way around, and we get our c value, which is just pi over 2. Pretty easy. Now, all that's left to do is just plug that back into our general solution. So we get y is equal to and I'm going to factor out the 1 over t on both of these parts. So y is equal to 1 over t times pi over 2, which is our c, minus the cosine of t. And I just switched those around, so it would just read a little bit better. But yeah, so that's our answer, and hopefully this was informative and helpful and wasn't too confusing. It's not scary, I promise. Yeah, thanks for watching, guys.